Hello，大家好。接下来介绍一下 CSpace System 的 High Availability Features。我是金子安，另外一个也有参与的组员是林静云。Okay, so for midterm, our overall goal is to set up Docker Swarm. And so, what is Docker Swarm? Docker Swarm is Docker's built-in tool for clustering and scheduling containers. Docker Swarm will detect node or container failures and reschedule workloads to healthy nodes to maintain the desired state, which is just a configuration that we set. Docker Swarm also has load balancing. It will distribute incoming traffic to available containers, ensuring no single instance is overwhelmed. So on each node, we will have a Docker daemon that will run containers on its own. But in Docker Swarm, these Docker daemons can communicate with each other, therefore forming a swarm. So why did we choose Docker Swarm? First of all, true high availability is impossible on a single machine, since a hardware fault or always crash will always cause downtime. So we need a multi-node architecture. Second of all, since our deployment workflow was already built entirely around Docker containers, Swarm was the most natural next step. And lastly, Docker Swarm provides the native failover and redundancy we need without the massive complexity and administrative overhead of Kubernetes. So on the right over here, we have our system architecture diagram. We have 3 nodes in total. Their IPs are 172.16.127.101, 107, and 108. Their host names are room 1, room 2, and room 3. Okay, so on over here, we can see that on each node there is one Docker daemon. And Docker daemons are responsible for creating and managing containers on its node. So in our case, Docker daemons, there are 3 Docker daemons on 3 nodes, and they can form a swarm. But by default, Docker swarms only run in standalone mode, which means it can only create and manage containers on its own node. But what we can do is we enable Docker daemons to run in swarm mode. And in swarm mode, they have the ability to communicate with each other, and then therefore forming a swarm. So what can Docker daemon do in a swarm mode? Docker daemons in swarm mode can create services, which is just specifies what container we want to run and how many containers of it, which is just the number of replicas. So in our case, we're running an Nginx service and a Django service. The Nginx service and Django service, they both have a replica number set to 3, which means we want 3 containers running in total. By default, Docker Swarm will try to distribute all the containers across all available nodes. And since we have 3 nodes and we want 3 containers, we'll try to distribute them evenly. Okay. And down here, we have some standalone Docker containers. And these are run by this Docker daemon on room 1. So what are these containers? These are a database, a local registry container, which is just a registry service that we use to host images that we built, the Nginx and Django images that we built, so that each Docker daemon on each host can pull images from here and then create containers over there. And AdMiner is just a web UI that allows us to manage or access the database more easily. Okay, and Nginx over here is just a web server, and Django is our backend. Okay, so how do users' requests actually come in, and how does our service respond to the requests? So in a Docker swarm, say Nginx listens to port 80. So we define that in our service. Then on each node, Docker will listen to port 80. So users' requests can theoretically come in through any of these nodes, port 80, and then it will distribute the traffic by this overlay network, which means if the traffic comes in from room 1, Docker Swarm will have some load balancing features that it can it can provide to distribute the traffic to any of these nodes inside. So so the user's traffic request might come in and then go here and then go to Django and then go to the database on room 1. Yeah, okay. So how does this give us some high availability features? So say on this node, room 3, a container dies, and after that, a darker daemon will notice that the container died. So what it will first do is it will try to recreate that container first. If it successes, then it can still process the user's requests. But if it dies, then the other darker daemons will know that this container can't live here. And then it will try to maintain the desired state, which means we still want 3 containers. And it will try to create a container either on room 1 or room 2, even though it's already running 1 container. And after that, this overlay network will stop forwarding traffic to room 3 because there are no more containers over here. And if any traffic comes into room 3, it will forward it to room 2 or room 1, which has the web server containers running. Okay, so that's for the case of 1 container dies. What if 1 darker daemon dies? So if this darker daemon dies, then these 2 darker daemons will know that because they can communicate with each other, and it'll say that this darker daemon dies. It can't communicate with that anymore. And when that happens, still the same. Darker daemons will, in this darker swarm, will ignore this node, and then it will create more containers to maintain the desired state. And then further traffic coming to either room 1 or room 2, it will only distribute this traffic amongst these nodes. So therefore, we have some high availability features here. Okay, so with that all being said, let's move on to the demo. Okay, so here we first connect to our server, and then we can first log in. And then we can try to make a reservation. So let's say we pick 3rd and 4th class, click class, click reserve, class is reserved. And let's SSH into room 1. And then we can see that there are 3 nodes. We have 1 stack, which is CSpace, that's running 2 services. CSpace Django and CSpace Frontend Nginx. Okay. So now we'll keep monitoring the statuses of the services, the backend and the web server, and then we'll SSH to room 2 and room 3 below. SSH room 2, and then SSH room 3. Okay, so now what we can do is we can try to kill containers with docker kill. And let's say we pick this backend container first, which is docker kill the container ID. Okay, it's been killed. And we can try to make another reservation here. So if we make a reservation, let's say HTTP 502, and then we make a reservation again, and it's done. So it's back again. Okay. So, yeah, it's back again. It's up 11 seconds. Now we go to room 2, and let's say we want to kill a front-end container. So kill it, and then we check. Reserved. Okay, it's nearly 0 downtime. And then what about room 3? Let's say we kill another front-end container. And again, reserve. And, well, it's running. It's back and running. Okay, so what if we kill two containers on two different nodes at the same time? So you pick a backend container and also another backend container from room 2, and then this time we kill two at the same time. Okay, try to reserve. Okay, we see that it's not working, and then try to reserve it again. Validation failed. Okay, the first time when I tried to reserve, it actually reserved. And if we try to reserve again, okay, the first time it actually reserved, but there were some front end bugs. So yeah, okay. Now what we can try to do is we kill two containers on the same host. So let's say we pick room 3, and we kill both containers running on it. Okay, and then reserve again. Oh, okay, cool. It's back up very fast. Now we try to kill. What we can do is we can try to kill all the containers at the same time and see what happens. So we just copy the IDs. And then we'll have to do it really fast. Okay. Reserve. Okay, failed. And bam, it's back up. Okay. So that's about it for containers. What if we restart the whole VM? Okay. So we can first try to restart room 2. Reboot. Yes. And then reserve. Down here. And yeah, we can still reserve. And room 3. Shut down. Reboot. Yes. Okay. Try to reserve. Okay, when these nodes go down, we can still reserve pretty fast. But if we shut down room 1, since the database is running on room 1, it wouldn't come back up really fast. So we try to reboot here. Let's set a timer, and we can try to reserve, and then it'll say API error because the whole database is down. Okay, so after speeding up all that, we can try to make a reservation again, and it's back. Okay, so that's all for the demo. And we can see a clear problem. That is, if room 1 dies, then we would have to wait for a long time. And that is because the database is only running on room 1. So what we're going to do next is we're going to put the database across all 3 nodes. And so we've studied how to do that, and it turns out to be just a little bit complicated. And this is just a rough plan, and therefore I'm not going to go into the details today. Okay, and that's all for our demo today, and thank you for watching.